In this video, I'll show you how to create a multiple linear regression model in Python, and I'll walk you through the whole process of using machine learning libraries. So make sure to watch all the way to the end of the video because you don't want to miss an important step. The dataset I'll analyze is a pretty famous one. It's on the red wine quality. So if you want to follow along with me, then I'll provide the link to that dataset in the description below. And with that being said, let's get right into it. Okay, the first step is to import one of the Python libraries. So I'm gonna show you what that is. First, say import pandas as PD, and this library is gonna let you load the CSV file. There's gonna be a lot more libraries we're gonna import, but for now, we're just sticking with the basic one before we dive into the machine learning libraries later. With the pandas library, you can easily load a CSV file into a data frame. So here's how to do it. The data frame is going to be called df, and you set that equal to pd, which accesses the pandas library, and you're going to use a method called readCSV. And inside this method, it's going to take in the file name of the dataset. So inside quotation marks, you're going to put the name of the dataset, which is going to depend on where it's located on your local computer. But there's one more argument. If you look at the CSV file in Excel, you can see that all the data is separated into semicolons instead of being organized into rows and columns. So over in Python, after you type in your first argument, the second argument's gonna indicate what the data is separated by. So you're gonna say SEP is equal to, and inside quotation marks you put in the semicolon. So if you run that and take a look at the data frame by saying df.head, which is going to return the first 5 rows of the dataset, then you can see that the data frame is neatly organized into nice rows and columns. Before we create our regression model, we need to check if our data has any null values. And if there are, then we need to make sure to remove them. So it just takes one line of code. You just have to say df.isNull parentheses .sum parentheses. And this is going to return how many null values there are for each column. And luckily, it turns out there's 0 null values in this whole data set. So that's less work for us. And now we can move on to the machine learning part. Our dependent variable is going to be the red wine quality, which is the quality column. Because we're creating a multiple regression model, we're going to have multiple independent variables, and they're going to be the rest of the columns in the dataset. And the model that we're going to build is going to predict the red wine quality based on the values of all the independent variables. So if you want to see me use machine learning libraries to do this, make sure to keep watching. First, we're going to say x is equal to df.drop, and inside this method, we're going to say columns is equal to the quality, meaning that this x variable is going to have all the other columns except for the quality column. So if you take a look at that, then you can see all the other columns, but you don't see the quality column at the end, which is what we want. You might be wondering why I used a capital X instead of a lowercase x. That's because it's just standard convention to use a capital letter for the x and a lowercase letter for the y. Now for the dependent variable, you just have to say y is equal to df, and inside square brackets, you just put in quality. And if you take a look at that, that's just going to return all the values inside the quality column. Now we got to split the data into 2 data sets, the training set and the testing set. The training set is used to train a model, and that model is fed into algorithms which help it learn to make predictions on the dependent variable. And the testing set is used to see how well the trained model performed. So let me show you how to implement this in Python. We're going to use a library called scikit-learn. So you got to say from sklearn.model selection import train test split, which is a package from scikit-learn. So if you run that, then you got to create 4 more variables: xtrain, xtest, ytrain, and ytest. And you're going to set that equal to train test split, and the first argument is going to be the x variable that we created up here. The second argument is going to be the y variable, and the third argument you're going to specify the test size, and you're going to say 0.2, which means that 20% of the data is going to be put into the testing set, and 80% of the data is going to be put into the training set. To show you that this worked properly, let me show you the size of the training and the testing sets. So type in xtrain.shape, xtest.shape, ytrain.shape, and ytest.shape. And if you run that, it's going to show you the number of rows and columns. So you can see that the training sets have 1,279 rows, and the testing sets have 320 rows. And this makes sense because more of the data went into the training data than into the testing data. Alright, now it's time to create the linear regression model in Python. You gotta say from sklearn.linear model import linear regression. And after you do that, you're gonna initialize the model by saying model is equal to linear regression with 2 sets of parentheses. The next step is to fit the training data into the model, and make sure not to fit the testing data, or else you're gonna get a model accuracy that's way higher than usual. Over here, say model.fit, and inside the first argument you put in the xtrain, and for the second argument you put the ytrain variable, and you run that. Now you can use this train model to create predictions on the red wine quality based on the testing data set. So here's the syntax. We're gonna say that the ypred, which is the predictions of the model, is equal to model.predict, and you're gonna pass in the xtest variable. We can see how well our model predictions are by finding the r-squared value, which is also known as the coefficient of determination. So we're going to import another package from scikit-learn by saying from sklearn.metrics import r2 score. And so all we have to do is do r2 score, and inside parentheses you're going to pass in the ytest variable, which represents the actual predictions, and you're going to pass in the ypred variable, which represents the predictions of the model. So if you run that, then that's going to get you a decimal of around 0.27, which tells you that around 27% of the variation in the wine quality is accounted for by the regression line. Alright, we're going to do one more thing. We're going to find the final regression equation for this data set. So we need 2 pieces of information: the coefficients of all the independent variables and the y-intercept. To get the coefficients, all you have to do is say model.coef with the underscore. You run that, that's going to give you the coefficients of each of the independent variables. Now we just need to get the y-intercept, and that's pretty easy to do. You just say model.intercept with the underscore. That's going to give you your y-intercept. So we have all the information, but you might be wondering what the equation is supposed to look like. You probably know that the equation of a simple linear regression is just y equals mx plus b. It's pretty much the same thing here, but this time the equation is going to be a lot longer because we're dealing with more independent variables. So it's going to be y equals m1 times x1 plus m2 times x2, and then plus mn times xn plus b. And n is going to represent the number of independent variables there are in the dataset. I'm going to take a look at x again to see what the column names are. And over here, I'll type in the final equation. So our y variable is going to represent the wine quality, and that's going to be equal to the first coefficient, which is this over here. And since that's scientific notation, there's going to be 3 extra zeros on the left side. So that means that the first coefficient is 0.00. If I look up again, 0.0064 approximately. And that's going to be multiplied to the first independent variable, which is the fixed acidity. And for the second coefficient, if I scroll up, that's negative 1.16, and there's no extra zeros. So you just have to say minus 1.16 times the second independent variable, which is volatile acidity. And basically I have to repeat this whole process with all the other coefficients until this whole regression equation is finished. Alright, so I finished adding all the other coefficients, so now we just need to add the intercept. And if we scroll up, we see that the intercept is around 9.55. So all I have to do now is just say plus 9.55. And if I just run that, you can see that this is our final regression equation for our multiple regression model. Okay, that's all I got for this video. Hopefully you found it helpful seeing me create this model. And as always, make sure to smash that subscribe button, stay up to date with my content. And if you're still here, then you might like these 2 videos that I'm about to show you. So over here on the left side is a video on 3 easy visuals to create in Python. And on the right side over here, it's gonna show a video on how to create a simple linear regression model in Excel. So I hope to see you in one of those videos, and thanks for watching.